Hey guys, this is Fred from Prettyfly Games, and this is episode 3 in how to build an online first-person shooter. In this episode we're going to go through how to handle the shooting over the network and also the health management and everything you need for your first-person shooter. I had my friends at Pixelland test the performance, and we have about 10 clients connected here and it performs pretty well. So let's get started with how to implement this in Unity. Alright, so now it's time to add shooting support for our game, and I've made some changes in the prefab sections. So I've cleaned up a little bit here and added a few folders: network, particle systems and player. So the network just contains the network runner, and the particle systems is something I created. It's a particle system for when you die and a particle system for when you fire the gun. I also added a gun to the player. So if we open our network player, we can see that the little dude now has a gun, and it's just a super simple thing. It has a cylinder and with a particle system in front of it, so you can get a nice fire effect. And we have a small aim point on top and a cylinder, so he can hold on to something without any hands. But that doesn't matter. So it's attached to the camera, so when the camera moves, the gun will move as well. And of course I created a few materials for the particle systems as well. I've also added a few sprites, so we have one sprite that we will use for the aim, and also a particle that we are using for the firing effect of the gun. And this is created by Kenny, and it's from his particle pack. So let's start by creating the UI. So let's create a UI, and we'll do a canvas for it, and we can call it in game or player UI canvas, so that we know what it is. And then let's change a few things on the scaling. So we want to scale with screen size, and 1920 times 1080 is the normal resolution for most screens, and let's match with half. So it matches the screen width or height based on both the width and the height, so it works on both ways. You can adjust this to fit your game's needs. So here we have that, and yeah, it's very far away, doesn't really matter. And it's a screen space overlay, so it means that it will be rendered on top of any camera. So right now we have our main camera here, and it is rendered on top of that, but later on it will be attached to the player and rendered on top of the player's camera. So let's create a UI. We'll do an image, and this is gonna be our aim point. So let's change this into aim, and it's currently 32, so that's a bit small, so let's just make it 96, and we'll position it in the center of the screen, like that. And yeah, so if we look at our player canvas, we can see now it has an image, and let's just call it aim image, so we know what it is. All right, so from this, let's create a prefab, call it UI, and player UI canvas, like that. And let's get rid of it. And what we want is for it to live inside the camera of the player. So here we can attach it again, UI, player canvas, drag and drop it, and we'll add it above the gun. Right. So if we save that and take it for a spin, you can just look at our main camera, it's gonna disappear. So if we take it for a spin now, we should be able to see our aim, hopefully. Yeah, there it is. And as you see, it's white, and if we're looking at the horizon, we're not gonna see very much. So that's something we want to change to make it more visible. And as you can see, we don't see the gun either. So the reason why we don't see the gun is because it has changed into the layer local player model, which means it's not being rendered. So if we change it to default and we wait a little bit, then it should be rendered if we actually change the correct model. So I actually changed the player UI canvas by mistake. Let's change the gun to default. And yeah, here we have it, our nice little gun. So now we have a first-person shooter, well, at least the starting point. Nothing happens when we are clicking. So let's fix the color first of the aim. So we can just go in, change color, let's make it black so it becomes easier to see, and then we can save that. So now we can actually start building the firing mechanism. So let's go into our scripts, and we'll go into our network and open our network input data in Visual Studio. So we want to handle firing in the same way as we do jumping. So let's add a is fire button pressed, and it's going to be a network bool, and let's save that. Then we go into our character handler, and similar to as we have a is jump button pressed, we want to have a is fire button pressed. And then what we want to do is, okay, we're going to check for jumping here, and we want to do the same thing for firing. So let's check, okay, is fire 1 pressed? Then we're going to say that, yeah, the is fire button pressed is going to be set to true. And then we want to supply it in our network data here. So let's make sure that it's included. So let's add that just after jumping. So network data is fire button pressed, and we'll set it to is fire button pressed. And then when we have actually sent the input away, then we can reset the variable. Awesome. So now that we're gonna hit our left mouse button, which is assigned to fire button or fire 1, then this is gonna be sent to the network, and the server will act upon that. So let's save and go back into Unity. So on the scripts, let's create a new folder, and we'll call it weapon. And in here we will create a new script, and we want it to be called weapon handler. And let's open that in Visual Studio. So there was just one tiny thing that I forgot to change in the character input handler, and there is an issue here, and we're running the update here, and it's running actually on all the clients. So when we're spawning a new client that is joining a game, we are running this as well on the server. So the server is running all of the clients' character input handlers. So we want to check if we actually have control over the object. And if we don't have control, then we shouldn't actually run any of this code. So we're gonna add a reference to our character movement handler later on, but we're gonna say, okay, does the object has input authority? And we're adding not. So if it doesn't have input authority, we're not gonna run this code. So to get rid of this error, we need to reference it. So let's do that. Other components, we already have that, and let's add our character controller here. And in the awake function, let's get the component. Okay, so that gets rid of some problems that we can have later on. So let's just save that, and now we can go back into our weapon handler. So the weapon handler is right now a mono behavior. And we're gonna change this into actually being a fusion network behavior. So let's change that. And what we want here is we want to be able to tell all the other players that, okay, we are firing. And we want to as well be able to detect if we are hitting anything, and then, well, do something if we are hitting something. But the first part we're gonna solve is, okay, we are going to start to tell all the clients when we are firing, so that they know that they should trigger the fire animation. So we add a public boolean is firing, and we are going to change it so it's going to be a networked variable. So this is one of the beautiful things with Fusion, is that you can have networked variables that are updated through the server on all the clients. And it's part of the magic of Fusion. So we're going to say that, okay, this is going to be a networked variable. But what we're going to say as well is that, okay, if it has changed, then we are going to actually call a function here called onFireChange. And right now it's saying that, okay, there's a problem because that function does not exist yet. So what we want to do is we want to change or actually add this. There is one little part which is a little bit different, and that is it's going to be a static variable. And I actually changed something in my code here, so right. So this is going to be a static function called onFireChange. And a static function can't access anything that is sort of in this area, which is non-static. So there is, however, a bit of magic that they have done for this, and that is that you have the ability to actually call a regular function through this static part. So what we wanted to do is we're going to add something called, or a new function as well, called onFireRemote. Because we want to handle it differently. Locally, when we are pressing the fire button, then we want to execute it faster. And remotely, when this is updating, we want it to be updated on the clients. But that could be with a slight delay because it's going through all the network hoops, etc. Let's add the fire function, and we'll do a void fire, and it will have a aim forward vector, so we know in what direction we're firing. But before we actually add this, we want to add a variable, because what we don't want is people being able to sort of auto fire, because then it becomes more of a sort of how fast is your ping, and if you have an auto clicker enabled. So let's limit how fast a player can fire, and we're going to say that, okay, last time fired, it's going to start at 0. And then the first thing we're going to check in this function is that, okay, has enough time passed. And what we're going to say now is 0.15 seconds is the time it takes for a player to reload. And after we have fired, we're going to say that, okay, the time is time.time after we have fired. And there is a network time, etc. But I think time.time will work fine enough in this case. And actually this part will be running mostly on the server. So it doesn't really matter, or at least right now I think so. So let's just stick with that for now. Then we can't run this regular update function because we are going to run things over the network. So let's change that into fixed update network, which in Fusion language is often referred to as fun, F-U-N. So in our fun function, we want to check, okay, have we received any input data? And if we have, we want to process it, and we are only actually interested in this case if the player has pressed the fire button. So if the player has pressed the fire button, then we want to fire our gun. So in that case we call fire with the information supplied in which direction they want to fire. Okay, perfect. So now what we want to do is that, okay, we can detect that we're getting a fire. This fire function is being called, but it's not being called on all the clients. It's only being called on the clients that are processing this data. So it means that the server will know about it, and the client that actually pressed the fire button will know about it, but nobody else will know about it. So they will not have any animation that the other player is firing. So what we want to do then is we want to toggle this fire variable. So it gets updated on the network and it will trigger an on fire change, and then we can handle the on fire remote here. So what we want to do then is we're going to add a coroutine. There are certainly different ways of handling this, but I think a coroutine is quite nice. So we're going to call this from fire and say, okay, we're going to start the coroutine, and the coroutine is going to say, okay, is fire is true. So it's going to change this network variable, and changing a network variable can only be done by the state authority, the server. So even if a local client is changing this variable, it's going to be changed back by the server, because that's the one that keeps all the record and is the authority. So then what we want to do is that, okay, we're going to wait for a short period of time, like less than 100 milliseconds, and then we are going to say that, okay, we are no longer firing. So the server is going to change this is firing for a short period of time. It's going to wait a little bit, and then it's going to say, okay, now we're no longer firing. This gives enough time for the clients to update, so they will actually get a on fire change, and they will be able to render the sort of the animation. So this information is only like visual, so it doesn't matter if it's slightly delayed. It's going to be pretty instant, but there is of course a network delay, but visually it doesn't matter, so we can use this on fire change or change management that Fusion is offering. Alright, so what we want to do is we want to fire our particle system when this happens. And the first thing we need in that case is we're going to add a reference to our particle system. So let's add that, and we'll say, okay, public particle system, fire particle system. And the first part is of course, okay, we are going to handle it sort of the local version first, and say that, okay, if we have reached our fire effect, or if we're running this and it's firing, and then let's play our particle system and say that, okay, we are going to play this, and it's going to render. But as I said before, it will only be rendered locally for the player that is pressing the fire button and actually the server. So we still need to call it. So let's have our routine call it after we fired and say that, okay, we are actually firing. Then let's start our coroutine, fire, and it will execute this code. And that will cause on fire change to be triggered. Now this will actually be triggered, which is a static function, but nothing else will happen based on that. So what we want to do is we want to check that, okay, has this variable really changed? And let's add a debug log to this so we can see what is going on. So we're going to add a debug log writing the time and saying on fire changed and value, and say that, okay, is firing is the changed behavior's value. So it becomes a little bit awkward, and you need to do it this way because it's a static variable or static function. So we can't say that in here, we can't say is firing is equal to true, because it is saying that, okay, it's a non-static field, so we can't access that. So that's why we need to go through this changed behavior is firing. All right. So what we want to check is if this has really changed, because as the server is doing a lot of things, it can actually trigger this change multiple times, even sort of if the variable has not changed in a way that we're expecting. So just making sure that we are detecting that it has changed from that we're not firing to that we're firing. Let's add a check for that. So we're going to say that is firing current is going to be change behavior is firing. And then we're going to say, okay, we want the old value. So we want to check what was the value before it actually changed. And then we can use this change load old. So that loads the previous value of this variable. So let's add a new variable called isFiring old, and we're going to read change behavior isFiring. So as we have loaded the old, this is actually going to be the old value, which is slightly confusing. So you have to really make sure that you're reading this line and saying that, okay, we have actually loaded the old variables, so this is not the current variables. All right, so that's an important thing to keep in mind. So when we are detecting that, okay, this has really changed, then we are saying that is the firing current, we are firing, and it was not firing before, then it means that we are actually going to trigger this on fire remote. And on fire remote, we want it to be triggered on all the client that does not have input authority. So we're saying that object does not have input authority, then we can fire it. Right, so if we look at our code, we're gonna get triggered this fire function because we have detected that the player has pressed the fire button, and we're going to start our coroutine fire. That's going to change our network variable is firing to true, and then we're just going to store the time that we have fired and continue. So if we save now and go into Unity, all right, so now we're in the game again, and yeah, we don't see the gun, so it's because the layers have not changed yet. And let's go in our gun, change the layers to default, and now we can see the gun. So if we are pressing the mouse button, we can see that, yeah, we have some fire animation, and we can see that the variables are changing. And if we bring in another client, let's move this to the side, and let's just wait for my slow ass computer to actually bring in the other client. Right. So the same thing here. He's not showing the gun. So let's change it to default. All right. So now he has a gun. And if we look at the scene view, there we go. We can see that, okay, we are running around with this other player. And yeah, if we're pressing the fire button, it is updating on the network as well. So let's zoom in a little bit closer so we can see that. So I'm hitting the fire button and it's updating on the network. And this is from the client. And let's have a look at the other way around. We can look at the server and say that, okay, when we are firing, it is updating. But right now we can't hit anything, so that's what we want to change. But now this on fire part is working well enough. So let's stop the client and change our script so we can actually start to firing for real. So let's go into our weapons handler and open that in Visual Studio. So now we have created our particle effect when we are firing, but we want to as well fire for real. And in this game, we are going to use something called Hitscan. And Hitscan means that we are actually not going to create any projectiles. We're going to fire a bullet that sort of hits instantly because it's a fast firing bullet. So when you're firing a sort of a round from a gun, it actually sort of hits in no time. It's different if you're firing a rocket, then it might take a little time before it arrives. But we're going to focus on the hit scan first. So with a hit scan, what you normally do is you use a raycast. So you use Unity Physics Raycast, and you're checking that, okay, have we hit anything? The problem with networking is that all the clients can be in different states. So they are not guaranteed to be 100% synced with the server. That means that, like, if you have one client, client A, and another client, client B, they might perceive the world differently. So if you look at from the eyes of player A, he feels that, yeah, I'm aiming straight at player B and I'm firing and I should be hitting. but player B could have lagged out and actually be somewhere else, and he feels that I'm not actually getting hit at all. So normally what you have is the server, that is the authority in the middle, that is deciding everything and making sure that the clients cannot cheat. But the world from the server's viewpoint is not the same as from the client. So this is a big problem for games, and you cannot only rely on what the server is seeing, because it will cause players to, well, not be able to hit each other at all. It will be very hard. So Photon has solved this in a very nice way. They are offering a sort of a method that they have created called a ray compensated or a lag compensated raycast. So we're going to use that. So runner lag compensated raycast. And this does a few magical things. It takes in sort of what the client is seeing. So it is somehow syncing it up with the client from the server side and making sure that this raycast is being performed from the eyes of that client. So it makes sure that it's, well, as accurate as possible. And it's a good way of allowing the client to not sort of only rely on the server. So it's a bit of magic. I'm not really 100% sure how it works, but it works. So the raycast is going to take in, similar as a regular Unity raycast, really. It's just an overload of that, where actually it offers the same parameters. So the first part is, okay, we are going to have some type of origin. Where are we actually coming from? And what we want to do is we want to have some type of aim point. So where are we aiming from? So let's add that here, public transform aim point. That's where the raycast is going to originate from. Where is it coming from? So we're going to say that, okay, it's going to originate from the position. It's going to have a direction, and we already know that it's going to be the aim vector that we have fed into our function. And then we're going to have a distance. How long can we fire? And we're saying just a random value 100. Then we need to feed in who the object input authority. So we're going to say that, okay, object input authority. That's how the server will be able to know who's firing and who's handling that part. And then we have an output and say that, okay, we have some hit information. And after that, we are going to say that, okay, what are we colliding with? Which layers? So we need to add as well a new variable, and it's going to be a layer mask, so that we can determine what layers we're interested in colliding with. The instructions for this lag compensation raycast is that, well, part of it should be in different layers to improve performance. So we're going to use different layers. So let's have our collision layers fed in there. And then the last part is an option, and saying that, okay, what are we interested in hitting? And there are two parts of this, and it's physics, which is included in Unity, is well, all the box colliders and things like that. But there is as well called Fusion has its own hit system as well. Which we're actually going to use, but we want to include physics objects as well. And the reason why we want to include these is because we want a player to be able to hide behind a box or something in the environment, and we don't want the ray to pass through that. Okay, so now we are firing our ray here, and then we need to analyze our hit information and see if we hit anything. But before we do that, let's add a hit distance, a variable, a float, 100. We're going to use this for debugging, and then we as well want to check, did we hit another player? And this will also be sort of used for debugging. So what we want to do for the debugging is that, okay, we want to be able to see, at least on the server side, what is going on. Yeah, so let's add a little bit of debug, and we're going to say that, okay, if we are hitting another player, then we are going to draw a ray from our aim position in the aim forward director, and it's going to be multiplied by the hit distance, which is 100 to start with, and it's going to be color red, and we're going to leave it for 1 second, so we can see that, okay, the ray is going to stick in the scene for 1 second. And this debug draw ray is only visible in the editor. And if we are not hitting a player, then we are going to say that, okay, we're going to draw a debug ray, and it's going to be color green. So red if we hit a player, green if we do not hit a player. Then we will add a check and say that, okay, if we have received hit information with a distance greater than 0, then we're going to use that as our hit distance. So the ray will actually be stopped when it is hitting something. And then in our code, what we will have is we will make sure that if we're hitting something, then this hit info will be populated. If we're not hitting anything, it will be, well, not populated. So the first thing is we're going to check that, okay, if there is a hitbox and it's not null. So a hitbox is something that is included in Fusion, and it's a way of handling network hits. So the first part is we're going to check, did we hit a collider that is a hitbox, which is then a Fusion collider. It's not a physics collider. If we did not hit that, then it means that we actually hit a physics collider, and that has some information. It has a collider, and if that is not null, then it means that we have hit a physics collider. And if we haven't even hit that, it means that we didn't hit anything in the world. So that's fine. So what we want to do is that, okay, if we are hitting something with a hitbox collider, we're going to say that, okay, we at the time hit a transform, the name, and we hit the hitbox, and we're going to write the name of that hitbox. All right. Then let's do the same thing for physics, so we know that what is going on, and we'll say that, okay, we hit a phys-x collider, and that collider's transform's name is. Awesome. Then what we want to do here is, if we are hitting something which is a hitbox collider, it means that we have actually hit another player. So we will make sure that we are updating our isHitPlayer. So it's saying that we have hit our player because that's the only thing that has hitboxes on it. And that's going to change our color. So for now, we're going to leave it as it is, and we're going to save it, and we're going to try it in Unity and see that our rays are working as they should. All right, so let's reduce the size, and I've connected another client, so let's bring that in as well. So we can run around, and let's have a look at our scene view. And yeah, where are we? Let's find the other player. And so now we're firing, and as we can see, we have the green ray coming out from this player. So when we are pressing the fire button, we can see that, okay, we have a green ray, and yeah, if we aim at the player, it is a red ray. So this system now knows if it has hit a player. It's green, green, and red. And in the debug log as well, I can see what I've hit. So we can see that, okay, hit physics collider, and yeah, so the code is working, but nothing is happening when I'm hitting this other player. And as well, I still don't see our weapon. So let's fix those things right away. So let's fix the issue first with the gun not being visible. And the reason why it's not visible is because all of the layers are getting hidden by the camera. So let's fix that by opening our utils and the utils script in Visual Studio. So this code here, set render layer in children, is the one that is responsible for changing the layers. So let's expand this and say that, okay, we want to change the layer of a transform, but we only want to do it in certain cases. So we are going to add a tag. So what we're going to say is if the tag is ignore layer change, then we will use the keyword continue. So continue will just loop the for loop and it will not execute this code. So if an object has the tag ignore layer, it will just loop again to the next object and continue until it does not have this tag, and then it will execute this part of the code. So perfect, let's save that and go back into Unity. So now let's go into our prefab, select player, gun, and here we have tag, untagged. So I already added a ignore layer change. So normally you would add tag plus press the plus sign, enter whatever it should be, and press save. But for some reason I already tested this before and have that tag. So let's just select it. So now we have ignore layer change as a tag, and let's go back and save our prefab. And now we can try it out and see that we actually have a gun that is being rendered. So let's just wait for the reload, and yeah, now we can see that, yeah, awesome, we have our gun and it's working. So perfect. So now we want to be able to handle the case when a player is shooting another player, and with that we're going to add a new script. So let's create a new folder and we'll call it HP. And we will create a new script, and we will call that HP handler, and let's open that in Visual Studio. Our HP handler will be responsible for when a player gets hit. It will reduce its HP and will also handle the case when the player dies. So first of all, we want it to be using Fusion, and secondly we want it to be a network behavior. And what we want to have is a few variables. So we want to be able to track the HP to know how much HP a player has. So let's add a byte HP. It doesn't have to be an integer because we're just going to track regular numbers. So a byte is smaller than an int, so let's use that. I mean, even if it's a tutorial, we can still do some optimizations. And the second variable that we want to track is going to be is dead. So we have a state for this player, and we are going to listen on the on change for on HP change and on state changed. So we need to add those functions later on below. But we also want to track a few more things. So we want to make sure that we have initialize this script properly before we start to using it, and also we need to have some type of starting value for it. So we're going to say that, okay, starting HP is going to be 5. So when we are starting up and reaching our start function, then we want to say that, okay, our HP is going to be our starting HP. So it's going to use this constant. Then we can get rid of our update function because we will not need it anymore. And then we can make sure that we have added these functions. So let's do a on change for the HP. And let's do the same thing for our state change, so that we have that as well. And both of them are static because that's required. Oops, sorry. So let's just fix this formatting. I will add code soon anyway. And then just make sure that we have clean code. We can say that instead is going to start as false. All right, perfect. So now we want to be able to reduce the HP of the player. And that is going to be done by the server side. So we need some method that exposes our HP and with the ability to reduce it and do some other things when we get hit. So let's add a function, and we will call it onTakeDamage, and it will be only called by the server, so I've added this comment. And the first thing we will check is that, okay, are we already dead? If we already are dead, then there is no point. We don't have to take any more damage because, yeah, well, we are dead. If we are not dead, then we will say that, okay, our HP is going to be -1. And then let's just add a debug log so we can see what's going on. And we can say that, okay, the time this transform name took damage and has HP left. So let's write that out so we know that it's being called. And then we want to say that, okay, if our HP is smaller than 0 or equal to 0, then it actually means that we have died. So in that case, let's add it to the debug log and say that, okay, we died and is dead is now true. So this function, we need to start to use it, and it's going to be used by our weapon handler. Alright, so this script is currently spamming a lot, so let's take this out with the onFire change value, because we already know this code is working, so we can just make sure it doesn't add it to the log all the time. So now we want to reduce the HP of a player when we are hitting it. So we already have our function here, fire, and we know that, okay, we have hit a hitbox, which is means that we have actually hit a player. What we want to check now is if we are the state authority, the server, or not. So if we are the state authority, it means that we can actually change the values of the other players. So in that case, we'll take the hitbox or hit info, take the hitbox, and take the transform and its root. And we're going to get the component HP handler, and then we are going to call onTakeDamage. So we assume that there is a HP handler attached to the root object. So that's a prerequisite that we have for our characters. Perfect. So let's save this and go back into Unity and see if it works. So let's open our player prefab, and we need to add our newly created HP handler to it. So let's drag and drop it over there, and then we can just save it. All right, so let's take that for a spin. All right, so let's bring in another client and just wait for it to initialize. All right, let's see where it is. All right, here we go. So now we have another client. Let's shoot that one, and let's have a look at our logs. And here we can see that, okay, awesome. So when we are shooting it, it is saying on change value. So it is actually registering that we are shooting it on HP change value. We can see it here. It went down to 2, and then 1, and then it says, okay, it's dead. And if we keep on shooting it, nothing more will actually happen. However, the other player can still run around and well, shoot you back, even though that they are actually dead. So we want to change a few things now, or add a few things. We want to make sure that when we are getting hit, we want to have some type of visual indication so that we know that, okay, we are actually hit. And we also want to be able to, well, kill the other player, so it gets removed from the game and can respawn. So let's get on with changing those things. So the first thing is to be able to know that we have taken damage. So we're going to do something super simple. Let's open the player UI canvas, and from here we are going to add an UI image, and we are going to change it so it expands in all directions. So let's just change the values to 0, so it covers the whole screen. And what will happen is when we are getting shot, we will have well, the whole screen will turn red. And then when we are, well, for a very short period of time, so we're going to do like flash red back, flash red back. Yeah, that's our function to actually have our player know that they have gotten shot. So let's just change it to damage, or let's say on damage image. And then we can start with having a transparent color on that so that it, well, doesn't show from the start. All right, let's save that. And let's go back into our script. So our HP handler. So let's open that in Visual Studio. So in our start method, let's use our is initialized, because we will need that later, and say that, okay, when we have completed our start, it's going to be initialized. And then we want to fetch a few components. So let's do that in our awake function. And first of all, we want to be able to change the color of the UI when we are, or this image when we are hit. So let's add a public color UI color, UI on hit color, and we want to be able to access that image. So let's say that we are going to use unity-engine.ui, and we are going to expose our image, or take that in as a public image, UI on hit image, so we can manipulate that. But our UI image is only visible to the player, so we want to have as well a way to show for the others that well, this player is actually getting shot by something. So let's use our mesh renderer for that. So let's get the mesh renderer for the body of the character, so that we can use that to signal that we are getting hit, and we are going to change the color as well of that. So let's just store our color default mesh body color, so that we have that. Okay, so this is perfect. Now what we want to do is we're going to say that, okay, when we are starting up here, we want to store the default mesh render color. So let's do that here and say, okay, default mesh body color is going to be the body mesh renderer material.color. So this is the value that we are going to change when somebody is getting hit. So for this, we're going to use a coroutine, and we're going to call it onHit CO. And what we will do is we're going to say that, okay, initially if we are getting hit, then we're going to change our body mesh renderer to the material color of white. So it will, the body will turn white. And if we have input authority over the object, meaning that, yeah, it is our object, we are controlling it, then we want to flash as well the UI. So in that case, we are going to change UI on hit image to the color of UI on hit color. Then we're going to wait for a little bit of time, like 0.2 seconds. And after we have done that, we are going to restore it the color of our object, and say that, okay, it's going to be whatever it was that it started with. And we will also say that, okay, if we are actually not, if we are the input authority and we are not dead, then we are going to reset the UI on hit color image to 0, 0, 0, 0. Well, actually we can just change the alpha, but no, doesn't really matter. Let's just do it this way. And then it will reset back and we will no longer see the image because we're setting the alpha to 0. Okay. So that's all good, but this needs also well to get called by something. So we want to be able to use this on HP change and on state change, but those are static variables. And as we said before, we need to make sure that we are adding actually local functions that can access our non-static variables. So let's start with the on HP change. What we will do is we're going to add a new function called on HP reduced. So we only care when the HP is going down and not up. And the reason why I'm saying that we're not going to care when it's going up is when it's starting here, then the value is actually 0. And then in the code, we are setting it to 5 because this is our starting HP. In that case, it's going to get flagged as an on change and say that, hey, the HP increased. But for we only care actually when we are reducing the HP, when we are taking damage. So how are we going to do this? First of all, we're going to say that, okay, when our HP is changed here, we're going to record the value like we did before. We're going to say new HP is our changed behavior HP. And then we're going to load the previous value, load the old value, and say that, okay, our old HP, what was that? So we store that. And then we are making a super simple check and say that, okay, if our new HP is less than our old HP, then it means that we have taken damage, so it has decreased. And if that happens, we're going to call on HP reduced. So then we end up in our code here. And on HP reduced, what we want to do is we want to check, first of all, are we initialized, so that we know that we can, well, safely do a few things. So yes, we are initialized if we have reached our start method, so that's all good. What we want to do then is we're going to run our onHit CO. So it starts the coroutine onHit CO. So that will execute this part of our code. So let's save and go back into Unity. So first of all, we need to assign a few of the things in the slots. So let's go into our player, network player PF. And we have our UI on hit image that we need to assign. And that is in our camera, player UI canvas, and on damage image. So let's drag that over. And then we have our body mesh renderer, which is going to be our body. So let's assign that here. And then we need some UI on hit color. So let's just take well, red, and then the alpha value, let's make it slightly transparent so we can still see things. All right, something like that. It doesn't really matter. So let's save that. And let's press play and see what happens. So now we have our player, and we actually have another player that spawned in. And if we shoot it, we can see that, hey, it's actually flashing. So perfect. Oops. Let's reduce the size of that so we can run the other client in the same window and bring it side by side, something like that. There we go. So now that we are chasing this other player, we can see that, okay, awesome. When we are shooting it, it's flashing. And now it actually died. We can see that on change is dead. So we can see that this player is actually red so it has already died. But in the code there's nothing to stop him from actually moving around and shooting back at the other player and killing him. So those are a few edge cases that we need to solve, and of course we want to make it maybe a little bit more visual interesting, and also make sure that the players is actually being removed so that we no longer can see them when they are dead. But let's start with making it a little bit more interesting when you die. For this project I created another particle system called particle system death. So if we add that, we can just have a look at it, and it's just spawning some blue things, and we're going to use that when a player is getting killed. So we're going to hide the player, and then we're going to show this little nice particle system. So let's go back into our code and open our HP handler in Visual Studio. So when we are dying, we want to do a few more things. We want to hide our player model so it no longer is being visible, and we as well want to make sure that we are spawning our pretty cool particle system. So let's bring in a public game object and death game object prefab. So this is our particle system that we're going to use. Now this is just a tutorial, so we don't really care about performance, but normally maybe you would use some type of pool to make sure that you're not instantiating objects at runtime, because that can produce some small jitter or lag. So we want to make sure that we are using pools whenever needed for stuff like this. But in this case, for this tutorial, we're just going to keep it super simple. And then as well, we want to have a few other components that we need to be able to, access. So the first one is going to be our hitbox. So our hitbox root is going to be used here to make sure that we cannot hit a player twice. So when it's dead, we're going to disable it. There are a few other approaches for this. I mean, you could despawn the player, and then whenever you want to respawn them again, you simply follow your respawn code for the network. But I often find it easier to just deal with it in another way, and that is sort of hiding the player and disabling all of the components that needs to be disabled when it's dead, and then we can just move it into a new position when it's getting respawned again. So we're going to add our on HP change, but our non-static functions. So let's add a private on death so that we can handle when we are dying, and also later on we're going to handle our revive, or that we're actually getting respawned again. So let's add a on revive. So in our hold on, sorry, I don't want that here. I'm gonna move that because I want it to be related to our on state change. All right, so now the code is more easily, well, you can read it more easily because on state changes has everything to do with it on, well, these things. So when we are getting our on state change, we want to say that, okay, if well, we're gonna do it exactly the same way as with the HP. So we're gonna say that is that current, well, okay, I called it new here, but well, anyway, you can change it and have the same names, but for some reason I called it is that current. And then we can load our old value, and then we can say that, okay, are we still dead? So is dead old? And what we want to do in that case is say that, okay, if we are dead right now, Then we want to say that we're going to call our on death here. But if we have become revived, then it means that we are not dead right now, but we used to be dead. So in that case, we are going to be revived. So let's call on revive in that change, or in that case. So now our non-static functions are getting called, and we can start access a few things here. So when on death happens, we want to take the player's model and we want to say that it's no longer going to be active. So set active is going to be false. And then we want to take our hitbox root and say that it's no longer going to be active, and say that it's active is false, so it will not get hit again when a player is shooting the place where the player used to be at. And then we want to create our very cool sort of particle system. So let's just instantiate it, and the death game object prefab at the position of the transform without any specific rotation. So that's all good, but the problem here is that, okay, the hitbox is going to get removed, but the character controller that we have actually has another hitbox, well, the capsule of it. So that's still going to be in the scene, and we are going to be able to actually bump into it. So we need to change that. So let's go into our character movement handler. So let's expose a new function, and we're going to call it set character controller enabled, and it's going to have is enabled as a parameter. And what we will say is that we are actually going to just use this field that is exposed. So we're going to take our network character controller prototype custom, and that can access the regular controller, the regular Unity controller for this, and we're going to say that it's going to be enabled and set that to whatever we have here. Okay, so let's save that, and let's go back into our HP manager. So then we need to fetch that and store it. So let's add our character movement handler, and in our awake function, let's get that. So let's just use get component to get it. Actually, we need to do the same for hitbox, because otherwise we're going to get an error because we haven't assigned anything to it. So let's get our component in children hitbox root. Perfect. So now we can also use that. So in death, let's take our character movement handler and set the character controller to be not enabled anymore. And then we can do the same thing for on revive, but reversed. So if we have input authority, then let's restore our UI on hit image color. And then our player model should become active, our hitbox should become active, and our character movement handler should be enabled. So then we can die, which disables everything, and then we can get revived, and which will restore everything. But getting killed and then getting revived and staying on the same spot isn't that interesting. So what we want is, when a person is dying, we want it to respawn. So we need to handle that in our character movement handler, because right now it's only checking for fall respawn. So let's enhance this a little bit. And in our other components, we are going to say that, okay, we are going to have an HP handler, and we are going to fetch it in the awake, so that we are using our get component and have that. And the first thing we want to do is we are going to check that, all right, are we dead? So if we are dead, it doesn't really matter about the input, because we don't want to move the character when we are dead. So let's make sure that if we are dead, we're just gonna return. And we actually can leave it as this, but let's make sure that we are also the state authority, so that we are the server when we are executing this code. Then when we are moving the character, we want to make sure that we are doing it inside our fun fixed update network function. So we want to have a way of requesting that we should respawn. So let's add that as a flag and say that, okay, is spawn requested? If it is, then we are going to do something about it. So what we want to do in that case, if we are the state input and we want to respawn, that means we have gotten is spawn requested, that we want to call a function called respawn and then return. Perfect. So then we need to add our respawn function. So let's go down here and yeah, we can add it here and say that, okay, on or respawn. So the first thing we want to do when we are respawning is we want to change a little bit how we did it before, because we have here manipulated the position, which is okay, but not the best way of doing it. So let's actually use a function exposed for this, and that is network character controller prototype custom teleport to position, and then we'll get a new spawn point. So this is the more correct way of doing it, instead of just changing the transform. Then we want to have some way, or actually let's restore our is spawn requested to false, because now we have done that, and we want to expose some public method of actually triggering this on spawn is spawn request, because it's going to be triggered from the HP handler. So let's expose our request spawn and say that, yeah, it's going to be true when we are calling this. And yeah, so as well with this check fall, let's beef that up a little bit and say that we are actually going to check here as well. Let's do this instead. Let's get rid of that, and we're going to say that, okay, if we are the state authority, then we're going to do something about it. The local client will not actually do anything about it. So if we are the state authority and we are falling outside of the screen, let's add it to the debug, and then let's use our respawn function so that we are using this code instead. Perfect. But what we want as well is that, okay, now that we have respawned, we want to be able to do something on the HP handler. So when we have teleported the person or the character, then we want to continue with restoring the HP and everything. So you could use different way, like events, to do it and things like that, but we're going to be extremely lazy just for this tutorial. So we are going to create a method in the HP handler that we can call, which is going to be on respawn. So let's save our character movement handler and go into our HP handler. So then let's add that. So we have a public on respawn, and we will set the HP to the starting HP, and we're going to say that is false. Now, the only problem is that we are actually not calling this teleport request. So let's change that. And we will add another coroutine for that. So let's go up and find our old coroutine. So we have our on hit. And then we are going to say that, okay, we have another coroutine, but it's going to be on the server side. So we call it server revive. And it's going to wait for 2 seconds. And then we are going to take the character movement handler and say that we're going to request a respawn for it. So we're going to use this coroutine when we have the server has detected on take damage and the character has died. Then we are going to start the coroutine server revive. Okay. So hopefully we haven't missed anything, but there is one little sort of iffy thing, and that's in our weapon handler. So right now we can actually fire our weapon even when we are dead. So that's not something we want to allow the player to do. So let's get our HP handler. And we will get it in our awake function, saying that, okay, we're going to get the component HP handler. And if we are dead, then we are not going to execute this part of the code. So we don't care about if there's any input because we are dead. So let's save all of this and try it in Unity and see if it works. So let's go back and open our network player prefab. And now we have a few things. We have our player model. So let's drag and drop that whole thing in there. And then we have the death game object prefab. So that's our particle system. There we go. And then we can save this and try it in Unity, and well, hopefully it will just work now. Alright, so now we can run around. Let's bring in our other client. Here we go, loading, and let's just position this here and bring the other one on. Right, my slow computer is not that fast. Alright, so he's looking down. Let's just look up a little bit. All right, so let's, well, that was some interesting jittering. Let's fire at him, and yeah, he got killed. And now he's over here, so let's kill him as well. And yeah, here we go. So now we can run around. We can kill the other player. And when he is dead, we can look around, but we can't walk around. And then we are getting revived again, and we can fire at the other player. So now we have essentially what we need for our basic first-person shooter. And actually there is an improvement that we can do, and it's that the prefab of the particle system will get spawned and it will remain in the scene, so it will, well, it will fill up the list of scene objects. So what we can do is create a very simple script, put it in utils, and we'll call it destroy game object. And let's open that in Visual Studio. And let's change this. So it will have a public variable called lifetime, and it will be an enumerator called start. So by doing this, we are actually starting a coroutine, and we don't have to do anything except for this. So there is no need to call start coroutine. And after the timer has expired, let's destroy game object. And let's save that and go back into Unity. Then we can go to our prefab particle system, open the particle system death, and take our script that we just created, destroy game object, and drag it in there. So there we have it, destroy game object after 1.5 seconds, which is more than enough for this particle system. All right, so let's save that. Then it will not fill up our world with particle systems. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. So I really hope that you enjoyed this video, and please give it a thumbs up if you did, and also hit that subscribe button and the bell if you want to get a notification when the next video is out.